Okay, let's go ahead and get started here. My name is Michael Haken. I'm a mechanical engineer at Facebook. And in this session, I'm going to introduce an indicator specification proposal. This specification seeks to standardize all of the indicators that we use, LEDs and panel graphics, on all of OCP hardware. So about 4 months ago, Facebook started an initiative to standardize all of our indicators in our OCP gear. And when we completed that spec about 2 months ago, we got some interest from the OCP community to develop a similar spec for all OCP hardware. And at that point, I translated what we had at Facebook into a more broadly applicable spec and started gathering feedback. So currently, this spec sits at Rev 0.3, and it can be found on the OCP Rack and Power wiki page. You can find it there. Rev 0.4 will be released shortly, so you can look for that. So let's jump into it. So the objective of this document is to adopt an OCP specification where indicators are clearly visible, consistent, accommodate colorblind data center personnel, only communicate actionable information, and do not conflict with other diagnostic tools. I like this objective because you can kind of read it like a list of past pain points. So let me go ahead and jump to the next slide to break this down a little bit. So I'll call these our guiding principles. So first, indicators should be consistent. This means having common symbols, having common LED colors, having those LED colors have the same intensity across all products, having the wavelengths of those colors be the same, and having any given LED color have the same message no matter where or how it's used. Second, indicators should have a purpose. They must provide some actionable information for data center personnel. This kind of seems like an odd requirement, but in the past we've had hardware deployed where hardware designers like myself will put in an indicator that seems to communicate some pertinent information to them, but in reality this information isn't used or consumed by folks in the DC, so this is an important distinction here. 3, indicators should be simple. That's to say that you don't need any reference documentation or a decoder ring to run around and to understand what a particular indicator is trying to communicate. This also means we want to stay away from things like blinking codes and things of that nature. We want it to be very simple. Number 4, indicators should never conflict with indicators on other products. Now, this is an expansion from the being consistent, but it takes it to the next step here. So let's look at this slide. This is indicator colors. The first thing you'll notice about this list is it's a very short list. There's only 2 colors here, and that's part of being simple. The next thing you notice is that it's only blue and amber. These aren't maybe the typical colors you would jump to or expect. The reason being is that 10% of males are colorblind, and we want to have everyone be able to understand and interpret the indicators that we have. So using blue and amber will prevent any issues with folks being able to see these. These are 2 colors that are at the opposite ends of the visual spectrum, so we don't have that issue. The next thing you'll notice is that there's a wavelength defined for both blue and amber, 470 nanometers for blue and 590 nanometers for amber. And there's also an acceptable range for those as well. And we can easily source LEDs that fit these criteria. We'll jump into the meanings of these colors in greater detail later, but for now, think of amber as a fault indication or a locate indicator, and think of blue as a power on or functioning, status good, links are active or links are not active. Indicator intensity. So there's 2 separate sections here. The first section applies to indicators that use light pipes. And in these situations, what we want to control is the luminosity, and that would be the units of CD per meter squared. So for blue, we use 1,000, and for amber, we use 2,000. This seems kind of strange at first to have indicators next to each other with amber being twice as bright. Well, in reality, twice as bright doesn't look twice as bright. That's the first thing. And the second thing is think about what we're using amber for. Amber is communicating faults, or if you're trying to find a piece of hardware, it's a locate feature. So in these cases, you want these indicators to be much more visible than all the background light noise that's in a data center. So that's why amber is much brighter. Also, amber is less apparent to the human eye as compared to blue at the same wave or luminosity intensity, that is. The second section applies any time you use an integrated glass globe for your light. And the reason that we don't use the same luminosity for these glass globes is that the brightness variation across the surface of the indicator varies significantly. So for these, instead, we use MCD. And you notice, again, we'll see amber is much brighter than blue. And in this case, we specify a minimum and a nominal value. So next is intensity view angle, right? So at plus or minus 40 degrees view angle horizontally and vertically, we want to control the luminosity, the brightness of these indicators by 25%, plus or minus 25% of the nominal value. And we also have a caveat in there is that whenever you can, we should satisfy plus or minus 55 degrees. The reason we landed on these numbers is that if you have a typical range for human height standing about a meter away from a rack, we want to be able to see all of the indicators on the top and the bottom of the rack. Next, crosstalk. We have a specification here saying that crosstalk should not cause an increase of more than 20 CD per meter squared in adjacent indicators. As to say you have two lights next to each other, and one turns on and the other remains off, we want to measure no more than 20 MCD increase in the adjacent indicator. And that's basically the minimal amount that you'll be able to actually tell. Next, indicator behaviors. We want our indicators to do only three things. They can be on, they can be off, and they can blink at a constant 1 Hertz rate. That's to say half of a second on and half of a second off. So what we don't allow here is blink codes that you have to look at it and get out your Morse code textbook to figure out what it's trying to communicate here. We want it to be very simple and easy. Next, indicator placement. Indicators should be on a visible surface on the front or back of a system. In the event that you have a tub that pulls out, it should be visible on that top surface, any viewing surface. And that's as viewed from normal to the front panel. And second, indicators should always be surrounded by a panel to reduce the background visual noise and provide a location for printed legends. This is important, and it's not done on a lot of OCP gear currently, but it will be moving forward. This is going to make it a lot easier for service techs to be able to see and interpret the indicators. Last, we say that anytime you have a indicator pair, which will be a common thing moving forward. That's to say you have a blue and amber couple. The blue will be on the left and the amber will be on the right. Or in the event that they're vertical, blue will be above and amber will be below. This is just to keep consistency so you know what to expect. So on this slide, we've had a lot of changes in the last month from the monthly OCP calls. So this one's going to be significantly changed in Rev 0.3 of the spec that I'll hopefully upload next month. But for this one, this defines all of the symbols that shall be used to define what an indicator is trying to communicate, right? So next to a board status, you'll have a little power symbol there, and it'll be the same for all products. The other thing to note here is that anytime there's text that's used, we specify what that standard text is. So you can briefly look over this table here and look that we have power on, we have AC good, DC good, fault or locate, status, fan symbols. So some of the changes that we're making in the 0.4 version is that we're going to try to stick primarily with symbols and get away from using text. This is so that we don't have to worry about language issues and we can have common symbols throughout. All right, this is the main slide here. This defines all of the indicator states. So first, I'll start with amber. Amber, when it's off, it means that there isn't any fault. If amber is on, it's indicating that there's a fault present. And in the event that it's blinking, that's a locate feature. So if a service technician is trying to find a particular drive in a service tub, they can go in their device, they can click locate, and then that drive that they're trying to service, whether it be functioning, non-functioning, that'll start to blink amber, and it'll be very apparent. Next, blue, if it's on, it can mean a module is on. it's present, it's functioning. If it's off, it means it's not present, it's not functioning, or not powered. And if it's blinking, that means that there's drive activity or network activity on that particular port. So in the event of a QSFP, for example, you'll have a blinking blue light on that QSFP module. And if the link is active and there is no traffic on that port, that'll stay solid blue in that case. The very last item on this table is a special case that we decided we wanted to include here, and that's for a blue-amber flashing on and off. This indicates a firmware update is in progress, and it does require a combined blue and amber bicolor LED. The reason why we wanted to include this is because we have situations where we update firmware on a lot of our products in the field, and in that event, we can't have anyone disrupt or hot swap or plug or disconnect power to these units, because it could potentially get us into a situation where we can no longer communicate to that device, and it could cause some problems. So anytime a service technician sees a blue-amber flashing indicator, it means you can't touch this. Next, I have some examples of how this gets used on hardware, but before I get there, does anyone have any questions? Yep.
How do you contend with like Ethernet ports that you said, you have green and amber there? Do you guys not use any green and amber Ethernet ports that have status information?
Yeah, so for those ports, we'll actually use blue and amber as well. So yeah, there are Ethernet ports. That's an excellent question. There are Ethernet ports that you can use these blue and amber LEDs. Yep. Anything else? Any other questions? Okay, so from here on forward, just interrupt me at any point, because we're talking about examples for specific products. So interrupt me if you have a question. That'd be fine. Okay, first, this is a system general power and control. In the left column there, in the middle, you can see the blue LED can either be on or off. There's no need to show traffic on a system power control LED. So that's either on or off. And then the fault, it can be on, it can be off. In the case that it's off, there's no problem. In the case that it's on, there's a fault. And in the case that it's flashing, it's trying to locate that particular module. This is very similar. This would be for a system general status or a health LED, sometimes they call it. Again here, very similar. We have blue. It's either on or off to indicate it's present or not present. And amber is indicating there's a fault or there isn't a fault. And for this, there's no reason to have a locate feature. So for a generic module or compute node status, this is much the same as the previous slide, but now you notice the addition of the firmware update in progress, that very last row there. So anytime we roll new revisions of firmware on our compute node, we don't want to disturb that process. And during that event, let's say if it has a bad hard drive and it's going to update its firmware at the same time, a service tech could arrive there wanting to swap a hard drive. They'll see that this light is flashing, and they won't pursue it. They'll have to wait until that firmware update is done. Everything else on this slide is similar as you've seen before. Yellow indicating locate when it's flashing. Solid amber indicating a fault. PSU status. So for this one, what I want to point out is the fact that there's multiple different failure modes that are being communicated here. And to do that, there's multiple LED locations to do this. So for a fault or location, or a fault LED on that middle column, that indicates a typical fault for the AC PSU. For a low voltage situation where this is still functioning, but it's not producing the right voltage, that's a separate LED location on that PSU. And it'll still have either on or off. That's all that LED can do. Now, there's many situations where you may not actually need multiple fault locations. Most of our products, you simply want to know whether or not it's functioning properly. And all the rest of the information that's provided is through a separate system. So that's something to keep in mind. Next is BBU status. We see a similar thing here where that we communicate multiple different failure modes. In this case, we have a general fault, we have a low voltage fault, and we have an end of life indicator. So something to keep in mind here is that in this case, you could have a BBU that is still functioning, but it's reached its end of life. It needs to be replaced, and it's showing an amber LED, but it is still functioning. And again, you don't see in this case, you do see the locate flashing LED, and that's only used for the far left fault location. This is how a QSFP would be done. In this case, you see there's only a single LED per port. For the LED being off, that indicates that the link is down. When the LED or the link is established, but there's no activity on that port, that'll be solid blue. In the event that a link is established and there's activity, you'll see a flashing blue. That's what 95% of the LEDs will be doing, flashing blue. In the event that there's a port error, it'll be a solid amber. And then let's say you're trying to identify a particular port because maybe you want to upgrade or there's something wrong with one of the cables. You can punch in locate, and sure enough, it'll flash amber, and that's how you find a cable. Hard drives. For the blue column there, you see that it can be on, it can be off, or it could indicate activity. Same for the amber. It can be off if it's working fine. It could have a solid amber for indicating a fault. Or if you want to locate a particular drive in a box, it'll flash amber. And here you'll see that there's another option for whether those LEDs are combined. That's the far right column, or whether they're separate. And the separate LEDs are preferred. This means it's easier to service this, and it's easier to tell what's going on if there's two separate LED locations, and that's why it's preferred. But you can use a combined LED if space is limited. Last item here is the fan module. This is very straightforward. Blue is just indicating on or off, and amber, again, fault and locate. Any questions? Okay, I'm going to be hanging out just outside this door. Ooh, another question, great.
So you said at the beginning of this talk that you basically build a spec based on what Facebook does?
Yep.
Okay, so how did you arrive at blue for your power on and blue states? And were there any historical precedents for you basically using blue? Because from some stuff that I've read, some things that I've seen, green is typically a power good state.
Yep.
So I know you said about the spectrum, you wanted things that were grossly different for each other, but were you basing that selection sort of in hindsight, where it was full available LED color at the beginning and then blue had this characteristic, or how did you do that?
Yeah, it's a good question. So really the reason why we're using blue and amber, the reason why it's blue and not green, like you're saying, you're absolutely right, green is more typical, and that's what's used widely in industry. The reason why we're using blue is because of color blindness. We want everyone to be able to differentiate these indicators, and that's the primary motivator for using blue and amber. Also, blue is still widely available, so it makes a lot of sense for us. Yep.
So how do you contend with, again, I'd say if you're a game changer, right? Facebook can change things and therefore people follow.
Mm-hmm.
But what do you do with other equipment that's not internally developed, or you have, I'm sure, switches or things like that have green?
That's an excellent question, yeah. So there's going to be situations where we have, let's say, a compute module, and let's say the NIC on that compute module has a green and amber LED on it, like you're saying. In that event, there's not a whole lot we can do if we're not the manufacturer of those modules. But we can ask for them to provide an additional, separate BOM for that. So in the case of the NIC 3.0, there's going to be multiple BOMs for whether it be green and amber or whether it be blue and amber like we want to do. So there's going to be some transition happening. Obviously, this has to only apply to future hardware. So this is a step in the right direction, I believe. And in the event that you're a system manufacturer and you want to sell to OCP, the community members, as well as some of your traditional folks that want to expect green and amber, you can have programmable RGB LEDs and have an LED controller sit there. And now the difference between those two BOMs that I described is really just a firmware difference. Now, there's some logistical nightmares going, making sure that the right gear lands in the right spot, but that certainly can be overcome.
That doesn't apply to the connectors, because the physical LEDs, there's only two control lines to it.
That's a good point, yeah. And in those cases, you can get connectors with LEDs that are non-integrated, or you can get the connectors where we will have RGB specified for those. That's true for QSFP, and it's true for RJ45.
Yeah, you just see this might generate additional SKUs because there are companies out there that require the typical green LEDs for some.
Yep.
Split.
Yep. Any other questions? Okay, thank you for your time. I'll be just outside the store for the next 30 minutes or so, and then I'll be by the Facebook booth after that. Thank you.